Ever pondered about where life began? The origins of life have always been a subject of fascination and speculation. Life, as we understand it, is incredibly complex and diverse, leading to over 200 definitions attempting to encapsulate its essence. But for the purpose of understanding its origins, we use a broad definition. Life is anything subject to Darwinian evolution. This definition allows us to journey back through time to the very first signs of life. Imagine a world nearly 4 billion years ago, a world teeming with microscopic organisms. These organisms, similar to modern ones, were the first signs of life as we know it, but they evolved from simpler forms of life that could have arisen over 4 billion years ago. But let's pause for a moment. Where did these elements necessary for life, such as carbon and oxygen, come from? They were created in the cores of stars. So, as long as there have been previous generations of stars, Earth-like life could exist in the universe. This leads us to a staggering possibility. The first appearance of life could date back to over 13 billion years ago, during the cosmic dawn when the first stars formed. Imagine that life as we know it may be much older than Earth itself. But could life have existed even before our Earth was formed? Could it be older than our planet? To answer such questions, we need to journey back in time, to the cosmic dawn, when the first stars formed over 13 billion years ago. In this vast cosmic theater, the elements necessary for life, such as carbon and oxygen, were birthed in the fiery cores of these stars. These elements, the building blocks of life as we know it, were spread throughout the universe as the stars lived and died, scattered by their explosive ends. Think of stars as celestial foundries, churning and forging the raw materials that make up everything around us, from the air we breathe to the very cells that constitute our bodies. It's a process as magnificent as it is complex, where hydrogen atoms, under tremendous heat and pressure, fuse to form helium. This nuclear fusion releases energy and sets off a chain reaction, creating heavier elements such as carbon and oxygen. Now let's introduce an intriguing concept. If the elements for life have been around for as long as there have been stars, could it be possible that life, Earth-like life, could have existed elsewhere in the universe? Consider this. Our planet, Earth, is relatively young in the cosmic timescale, a mere 4.5 billion years old. But the universe, on the other hand, is approximately 13.8 billion years old. That leaves a window of more than 9 billion years before Earth was even formed. Could life have taken root during this immense span of time? The universe is a vast place filled with countless stars and potentially just as many planets. And if the conditions were right, the seeds of life could have been sown long before Earth came into existence. So, life as we know it might be much older than Earth. But Earth is not the only planet that could have been a cradle for life. In the vastness of the cosmos, our home is just one of the countless celestial bodies. And it's entirely plausible that life, as we understand it, might have sparked into existence elsewhere, even before it did on Earth. Consider our neighboring planets, Mars and Venus. These celestial bodies, much like our own, may have once boasted conditions suitable for life. Over 4 billion years ago, these planets could very well have been teeming with life forms, perhaps even mirroring the microscopic organisms we see on Earth today. Let's paint a picture of early Mars. This red planet in its infancy could have been a warm, wet world with a thick atmosphere. The presence of water is a key ingredient for life as we know it, and Mars may have had it in abundance. And what about Venus? Today, it's a hothouse with surface temperatures hot enough to melt lead, but billions of years ago, Venus might have had a temperate climate and vast oceans. These conditions could have provided a fertile ground for life to take root and evolve. The idea that life could have blossomed on other planets before Earth is not just a fascinating concept, but a possibility supported by science. The elements necessary for life, such as carbon and oxygen, are created in the cores of stars. As long as there have been previous generations of stars, Earth-like life could exist in the universe. This hypothesis not only broadens our understanding of life beyond the confines of our blue planet, but also poses an intriguing question. Could we be not just Earthlings, but descendants of interstellar immigrants? Could we be the descendants of interstellar immigrants? Now brace yourself for a thrilling possibility: life without chemistry. Let's delve into the theoretical concept of dark life. This is a fascinating and somewhat mind-bending idea that challenges our conventional understanding of life. It suggests that life might not always be bound by the constraints of chemistry as we understand it. Sounds like something straight out of a science fiction novel, doesn't it? But remember, reality can often be stranger than fiction. Consider the earliest moments of the universe just after the Big Bang. The forces of nature were in a state of flux, a chaotic dance of creation that was unlike anything we see today. Amidst this tumultuous backdrop, it's theoretically possible that complex structures could have formed. These structures, though unlike any life forms we know, could have had the ability to store information and self-replicate. This is the very essence of life, as defined by Darwinian evolution. The ability to carry and pass on information and the capacity for change and adaptation over time. These dark life forms would not have been made up of carbon, oxygen, or any of the other elements we associate with life. Instead, they would have been composed of pure energy or other exotic forms of matter. They would have existed in conditions vastly different from those we find on Earth, or indeed anywhere in the known universe today. But here's the catch. These theoretical life forms would have existed for a very short time, at least in cosmological terms. The universe rapidly cooled and expanded, and the conditions that might have supported dark life quickly vanished. Yet for these beings, this fleeting moment could have been their entire lifetime. They could have been born, evolved, and then vanished, all in the blink of an eye, on a cosmic scale. As far as we know, they left no trace, no fossil record. Their existence is purely speculative, a thought experiment that pushes the boundaries of our understanding of life. These beings would have lived for a fleeting moment in cosmological terms, but to them, it could have been a lifetime. So, what does this all mean for our understanding of life's origins? Let's take a moment to draw together the threads of this cosmic tapestry we've been weaving. We've explored the enigma of life's beginnings, delving into the idea that life on Earth has existed for around 4 billion years, but its true origins remain an open question. We've considered over 200 definitions of life, but for our purposes, we've stuck with a broad one. Life is anything subject to Darwinian evolution. This definition has allowed us to look back beyond the appearance of microscopic organisms similar to modern ones, at least 3.7 billion years ago, to simpler forms of life that could have emerged over 4 billion years ago. We've journeyed to the cosmic dawn over 13 billion years ago when the first stars were born, and pondered the possibility that the elements necessary for life, such as carbon and oxygen, could have been created in the cores of these stars. This opens up the tantalizing possibility that Earth-like life could have existed in the universe as soon as there were previous generations of stars, pushing the potential appearance of life back to the cosmic dawn. We've also ventured into the realms of the hypothetical, considering the possibility of extraterrestrial life on planets like Mars and Venus, and even the concept of dark life, life without chemistry, that could have emerged in the early universe. We've contemplated the idea that the forces of nature in the earliest moments of the Big Bang could have supported the growth of complex structures capable of storing information and self-replicating, enabling Darwinian evolution. This journey has led us to a humbling and exhilarating conclusion. Life, as we know it, could be much older than Earth, and could have existed in different forms and places throughout the universe. Perhaps we are more cosmopolitan than we ever imagined. In the grand scheme of things, we are all children of the cosmos.